Okay, now you learned a little bit about the structure of an IPv4 address. Each address has a network portion and a host portion. Of course, there are different ways of sending information from a source to a destination. Unicast is one where I'm transmitting information between one device to another device. It's a one-on-one communication. So that unicast packet has a destination IP address and a source destination IP address, and that destination address goes to a single person, a single device. So that just knowing that it goes just to one device. You look at this picture here. It's saying I got a source destination of 172.16.4.1. So I'm going from this device here to 172.16.4.253. What is that? That is this printer here. So it goes to no other devices. It's going straight from there to the switch to the printer. It doesn't go to any other device. It's a unicast address. And you can play the video and see just how that packet goes through. The second type of IP address is a broadcast. Now, a broadcast refers to the device sending messages to all devices on a network, kind of like in a one-to-all communication. The broadcast packet has a destination IP address of all ones in the host portion. So you got to get the network part, and in that host part, whether it's 8 bits, 16 bits, or 3 bits, if they're all ones, it's a broadcast address. Now, keep in mind, IPv6 doesn't have a broadcast address because there are so many addresses. I can make everything unique, a one-on-one. So basically, a broadcast address must be processed by all devices in the same broadcast domain. A broadcast domain is an area in the network that identifies all hosts on a same network segment. Now a broadcast can be directed or limited. A directed broadcast is sent to all hosts on a specific network. A limited one is sent to 255, 255, 255, 255. And basically, so it just broadens everything out a little bit. Now, one thing happens. Switches forward all broadcast messages by default. Routers do not forward broadcast messages. So that's a key difference between switches and routers. I'll let you look at the videos on limited now and on the IP directed. Now the third type is you've seen one-to-one, one-to-all. A multicast is kind of like a one-to-many broadcast. So it doesn't go to every device. It goes to all devices that kind of subscribe to that multicast group. And usually a multicast has an IPv4 address reserved, and it's reserved from the range of anything that starts with 224.0.0.0 all the way to 239, 255, 255, 255. So this range is a multicast range, and you'll see other routing protocols when you get into later classes. OSPF uses that quite heavily as far as communicating amongst other routers to pass on information. But it's just basically you got broadcast goes to everybody, one-on-one goes to one-on-one, one device to another device, and a multicast goes one to a select group that subscribes to that group. And this just gives you a rough idea of how that plays out. Watch the video and watch it goes through. I think what I'll do, let's go to types of IPv4 addresses just in the same video here. Now, there are several different types of IPv4 addresses. Now, because of IPv4 has a limited range, there only public addresses can be addressed or routed on the internet. Private addresses keep you on a local network. So back in the mid-90s, I think, gave away the last IPv4 address, so they needed to come up with a way of saying, I need to have an address. So they created private addresses. So this long-term solution before, in solution to the IPv4, address depletion, and before IPv6, is to create classes of IP addresses that can only be used internally and not externally. Now, the addresses you want to make sure you know these. The private address blocks is for a Class A network. For very large networks, a private network will start with 10 in that first octet. So it'll start from 10.0.0.0 all the way to 10.255.255.255. The medium-sized companies use a Class B private network. It's 172.16.0.0. And this one is Cisco likes to play games with because look at the ending range. It starts at 172.16.0.0 and goes to 172.31.255.255. So it doesn't use all the block of the 172.16 range. It uses a portion of it. So you want to pay attention because Cisco loves playing right around that borders. All of a sudden you may see an IP address is, it's 172.32.10.10. Is it a public or a private address? It is a public address. It falls outside of this realm. And then for a Class C network, the private address is 192.168.0.0, and then it ranges from 168.0.0 to 192.168.255.255. So these are the three privates. You got a Class A private that starts with 10. Class B private address starts 172.16 to 172.31.255.255, and you got the Class C private network block of 192.168.0.0 all the way to 192.168.255.255. You're going to want to know those ranges. Because when you're routing a network, you want to run through and send out information to Google. What has to happen? I've got a private IP address that's in my network at school, and to go to the public, I have to translate it into a public address. That's what network address translation does. It translates private IP4 addresses into public IP4 addresses, and it uses that network address translations. So a lot of organizations, the router's what's doing this. So you've got this private IP4 address range in the intranet, and it hits the router, and the router has to convert a public or a private address into a public address before it can run out to the internet, or in this case, you're seeing the example, into the DMZ, the area that's set aside by a company to kind of give some information accessible to outside clients, but not everything to the entire system. You want to double check, this little game as to deciding whether you, based on the address, do you pass it or go through? Not too bad. But there are some special IPv4 addresses that you're going to want to become familiar with. One is the loopback address. Loopback addresses usually starts with probably the most commonly one is 127.001. And basically all it's doing, if you ping that address, all it's now doing is to make sure that the protocol stack is working, so that layers 1, 2, and 3 are working correctly on that particular device. But it's just kind of you're pinging back on itself, making sure everything works fine. Now, there's a link local address. Now, if you ever got on a PC and all of a sudden you looked at your IP address and you see 169.254, that is an automatic private IP addressing that you see a lot of Microsoft issues. And usually what that happens is Windows DHCP, there's either no servers available, no lines available, and basically what it allows you to do now is I can only connect to peer-to-peer networks. I cannot get on any other devices. So just keep that in mind. If you see 169.254, automatically know your DHCP, you got an invalid IP address, you really can't go anywhere. Because most of us don't use ad hoc peer-to-peer connections very often. Now, back in 1981, IPv4 addresses put together in what they called classes, kind of put them into sizes based on how many clients they had. And basically, since you had private networks, I can't give AT&T a small number of private addresses. I've got to come up with a class that's very large for their organization. So they organize these in 3 different classes. Class A, gives you the largest, gives you 16 million host combinations. So it ranges from, of course, we said the private address for the Class A range starts with a 10. Class B, now you're going to want to know these Class A ranges, because usually what you're going to do is you can look at the class, you can look at that first octet and determine which class you're in, Class A, B, or C. In this case, Class 0, I'm in Class A, so what's my private range? It starts with a 10. So that's the first decision point you're going to make. Then if I look at the Class B, you're going to look at that first octet and say, oh, it's in that range between 128 and 191. Bingo. That means it's a smaller class. It still gets you 65,000 hosts, but it's still a smaller class. Now my Class B private addresses is in that 171, address that we saw up here earlier. Let me get back up here a little bit just to see. 172.16. And then Class C is 192 all the way to just before, so your 224 addresses. So you want to look at that first octet. If it's 0 to 127, it's Class A. If it's 128 to 191, it's Class B. And if it's Class C, it's 192 to 223. So you want to make sure you understand those ranges, and then you know which private address range to associate with this class. Now, there are also Class D, which are used for Class D is for multicasting, which we've talked about, and Class E, which are experimental. But usually you're going to spend most of your time in Class A, B, and C, especially in this class. It gives you a rough idea on how sizes they are, how many networks are available, how many hosts per network are available. And you go how do they do that? Well, remember, subnet mask says if it's a 1, it's network. If it's a 0, it's a host. So if I look at this class C network, it says it got 2 million networks. So what did you have? You had 255, 255, 255. You had 24 ones. So there's 24 network bits. So 2 to the 24th. Guess what number it is? You got it. So that's something to keep in mind. Now, who assigns all these IP addresses? In this case, there are organizations scattered around the world that is responsible for assigning regional IP addresses to ISPs. So they assign a block to a particular ISP. When you get a new phone or a new access point or something, one of these regions have allocated a block of addresses to your ISP that they can assign to. So we're in the North American region, so the ARIN, American Registry of Internet Numbers, is what does the North American range. But this is where I want you to do some practice on public and private addresses, looking at the address and say, okay, 172.16.35, is that public or private? Well, because it's 172 says, oh, it's a class B, so what's the private range of a class B? Well, it's 172.16.0 to, what do we say, to 172.31.255.255. That falls in the private range. I could not broadcast this on this. The same thing with the next one, 192.168.3.5. Because now I look at 192, it says, okay, that's a class C. What's my class C private address range? It starts with 192.168.0.0 all the way up to 255.255. This one falls in the private range, cannot be routed on the internet. So you want to play with this and do as many of these as you can to practice which ones are public, which ones are private. The more you get comfortable making that decision, the better you're going to like it. And then I would also go through and do the quiz, and just to make sure you understand all those ranges. So the next video, I'm going to talk about how do I segment a network. Talk to you later.